This morning on Today's Health, a computer chip that could be implanted under your skin so doctors can quickly access your medical records. The FDA just gave a Florida company the go-ahead to do it. You might recall about 2 years ago, a family was implanted with the VeriChip right here on the Today Show. Scott Silverman is the chairman and CEO of Applied Digital Solutions, the maker of the VeriChip. Scott, good morning to you. Thanks for joining us.
Good morning, Lester.
Explain to me briefly what the VeriChip is and what it is supposed to do.
VeriChip is a tiny miniaturized RFID, or radio frequency identification microchip. It's 11 millimeters by 1 millimeter. It's about the size of a grain of rice.
Well, we've got one sitting there by a penny to give us a little perspective of the size. Very
Correct.
tiny. You implant it under the skin how?
It gets injected, just like getting a shot of penicillin or any medicine that you would get in a doctor's office. It goes in the upper right arm, which is the area that our physicians have chosen for ease of access as well as biocompatibility.
And in a minute we'll talk about how you scan it, but tell me what information is on that, why that would be of great use if I show up in an emergency room.
Yeah, on the chip itself is only a unique identification number, and VeriChip can be used for the medical application as well as the security or a financial application. In the case of a medical application, on a database that ties to the chip, you can provide all your medical information, such as medical device information, medical records, and personal information. You choose what information goes on there, and you choose the type of affiliates, such as emergency rooms, that could have access to that information.
Is this the same thing that I have implanted under my dogs? I know this sounds horrible, but they did something on my dogs where if it gets lost, you can match the dog
Actually, it's not horrible. Our sister company, Digital Angel Corporation, manufactures a product that Shearing Plow distributes by the name of HomeAgain. HomeAgain is the implantable microchip for dogs and cats.
Same technology.
Same technology. Millions of them a year go into dogs and cats around the world. In fact, a few weeks ago here on the Today Show, you had the American Kennel Club who actually scanned a dog on national television with our chip and our scanner.
All right, enough about dogs now.
Yep.
Again, you go to the emergency room, this information is there, but to access this, the hospital has to have the scanning device. How soon will hospitals have the technology to match up with this chip?
Well, thanks to the FDA and their diligent work over the last 2 years, we now have the clearance to go to market with both the chip and the scanner.
All right, show me how this works, because you've got a scanner here, and you have a chip implanted. Is it underneath your right arm?
It's in the right arm. You power up a scanner, and you simply scan the arm. And once you scan the arm, you'll see that the identification information.
And on the laptop here you have it hooked up to, it says some number, but that doesn't tell me anything about your health condition now. From that number, they access your health records.
Right, that's correct. If you go into further detail on the database about Scott Silverman, it'll have my driver's license information, it'll have medical information, it'll have financial information, and it'll have security information for ingress and egress into facilities.
All right, you hear the sound of the background, people saying, Big Brother, too much information, a little scary. How do you respond to that?
Well, you know, it's interesting. I used to get that question a lot 2 years ago. Today, we've gotten it a lot less. In fact, the Attorney General of Mexico and some of his staff have received this chip for security purposes, and when the acceptance rate of the product goes up significantly like it has, some of the privacy concerns go down. But to answer your question directly, Lester, what most people are concerned with is the invasiveness of this, that it goes in your body. And as we know with pacemakers and other medical devices, that when people accept it for its applications and for its ability is when it'll work its way into society. It won't be tomorrow, it won't be next week, but 2, 3, 5 years from now, slowly but surely, it'll work its way into the mainstream.
All right, Scott Silverman, thanks very much for coming on and talking about this.
All right.
Appreciate it. It was good.
Hey everybody, thanks so much for joining us here today once again at smallcapvoice.com. And as you just heard, I am your host, Stuart Smith, and we are welcoming back to the show Positive ID Corporation. The company's traded on the over-the-counter bulletin board exchange under the ticker symbol PSID. Now, you might recall we had the chairman and CEO, Bill Cargill, on the show, I think it was around middle of February, and at that time we went over the basic building blocks of the company, the management team. We went over kind of the 10,000-foot view of the company, and today we want to talk about the Glooko chip. There's been a lot of news about that out here. Take a look at the press wire for the company. Follow along with that news. Again, to do that, use that ticker symbol PSID, or just visit us right here at smallcapvoice.com. So without any further ado, let's welcome back to the show the Chairman and Chief Executive Officer, Bill Cargill. Bill, how are you today?
I'm doing well, Stuart. Thank you very much. It's great to be back with you.
Well, thank you. You've been a very busy man. We appreciate your time here at smallcapvoice.com. Let's talk first about some of the recent news. Monday, March 5th, Positive ID Corporation finalizes first-in-class development of a fully synthetic glucose sensing system, a critical component of an artificial pancreas. If you would, Bill, please provide us your personal insight into the significance of this achievement, this development of a fully implantable glucose sensor. How does it work, and what makes this applicable to an artificial pancreas? Go ahead, Bill.
Stuart, we started this process a little over 3 years ago, and the product Glooko chip began with a piece of intellectual property and a patent that we own for an embedded biosensor. What we importantly did 3 years ago is we coupled with an expert chemistry company by the name of Receptors, who on their proprietary technology platform, for which we have an exclusive license for glucose sensing, has developed a glucose sensor that will go at the end of that microchip. So the product, which will, again, be about the size of a grain of rice, can be inserted into the interstitial tissue to measure blood plasma in the interstitial fluid and be able to take real-time blood glucose readings in vivo, which can then be read through a RFID scanner when passed over the injection or insertion site. What we importantly announced this week was the completion of the glucose sensing system, which includes the testing and the proof of product that the technology and the sensing platform works in blood plasma. What that means is it brings us to the next stage of development, which is to couple the sensing and the electronics into an integrated product and then encapsulate it in the biomembrane that we're actually currently testing and had a previous announcement on our preliminary test results with the Diabetes Research Institute down at Jackson in University of Miami. So bringing this all together is very important because if you think about the artificial pancreas project and its importance to type 1 diabetics, there are two sides of that equation, and the one that we've been focused on is the ability to be able to take continuous glucose readings and have continuous glucose monitoring, which will then allow for the other side of that equation, which would be the insulin pump, to be able to provide the appropriate levels of insulin to mimic the functioning of a healthy insulin-producing pancreas. So the major development that we've been working on is to provide that continuous glucose monitoring element, and through our testing, we were very proud to announce that we believe we've solved that part of the equation, and now we'll work with our partner to integrate the two pieces together into an integrated product, of course, including the development around the semi-permeable membrane that we've been working on and testing with the Diabetes Research Institute.
Well, it sounds like an extremely intricate process. What remaining developments are ahead?
Well, importantly, we need to finish the study that is ongoing with the DRI down in Miami to be able to test the life and biocompatibility of the membrane. Because when you think about what I described, which was a microchip the size of a grain of rice, and the fact that it will sit in interstitial tissue, it's integrally important that it maintain a semi-permeable membrane for an extended period of time so that that membrane doesn't foul and thereby render the device non-functioning because of biofoul, scar tissue, or otherwise clotting around the microchip itself. So we were very pleased with the intermediate step progress that we've made with DRI in testing in rodents, and we'll continue that study throughout the course of this year. At the same time, we're going to begin the design of the electronics that go between the sensor on the tip of this microchip with the antenna and the onboard electronics of our embedded biosensor, so that as we complete the process of testing the semi-permeable membrane, we can have an integrated product that would then be ready for system testing, full boat, the entire product. And it's our goal to be at the prototype level during 2013.
And what kind of IP protection do you have? That's intellectual property protection. What do you have in place to protect these great ideas that you're developing now?
There's a couple levels of protection that we have. The first is on the embedded biosensor, or the microchip upon which this sensor sits. We have a patent that was granted in 2007. So that's the first level of protection. On the sensor itself that we've developed in conjunction with our partner Receptors, they have an extensive patent portfolio that protects the technology and the science around their sensor development, and we, Positive ID, has the exclusive license for the use of that sensor technology and intellectual property in this product and any product with focused on glucose sensing. So when you wrap that together, we believe we have a very unique position with a very strong level of intellectual property protection.
Well, let's jump into another press release. Positive ID achieves positive preliminary results from Diabetes Research Institute study at the University of Miami. Bill, if you would, explain the significance of these positive results for us.
Well, Stuart, that goes back to one of the steps I talked about in the product development. And importantly, when you think about the sensor coming together at the end of the microchip and then covering it with the semi-permeable membrane, it's critically important that that semi-permeable membrane, while sitting in interstitial tissue, can defeat the biofoul process, or some of the natural defenses that the body puts up to any implanted device, so that there can be a constant and equal flow of blood plasma through the semi-permeable membrane. So about 6 months ago, we initiated a study with the Diabetes Research Institute to test those semi-permeable membranes that we've designed for this product, and to test them in a rodent study, again testing the extended periods of time of biocompatibility through the passage of blood through the semi-permeable membrane. We announced not too long ago the positive preliminary results from that study. We need to extend the duration of that study through the end of 2012, and we're hopeful that the results that we continue to see demonstrate that this membrane construction will work and will work for an extended period of time with relation to this product.
This is a massive market in the U.S. alone that you're tapping into with the GlucoChip. And listeners, look at the press release. There's some statistics in here. What percent of the 25 million children and adults with diabetes would be able to use this GlucoChip?
All diabetics would be able to use the GlucoChip for the purpose of taking real-time blood glucose readings. The subset of the market that encompasses type 1 diabetics, where you extend the utility to part of the artificial pancreas project, ranges, depending on estimates I've seen, between 5 to 10% of the total marketplace. So this is a product that has utility for all diabetics, but as it relates to artificial pancreas, that's a type 1 focused product. Again, do both sides of the equation, which is the continuous glucose monitoring, and then the ability to deliver insulin against those readings.
How do you expect to market this product, and what would this mean to your company from a financial standpoint?
Well, Stuart, given the size of the market and the size of the problem of diabetes, both in our country and internationally, I think the end answer is that the market opportunity is huge. How a company of our size, but with our very substantial intellectual property platform and product development, will be able to get into that market and to be able to have success in bringing this product to diabetics to improve their lives. will come through important partnerships that will develop both on the sales, marketing, distribution, and manufacturing side of the equation. As you would imagine, with announcements like the ones we've put out in the development that we've been working on as it relates to this product for several years, we are engaged continuously in discussions with interested parties, and I think a clear sign of our progress will be demonstrated over the course of the next year as we begin to line up the type of partners who are going to help us bring this important product to market.
Well, listeners, once again, we are speaking with Positive ID Corporation, and we are thankful to have their chairman and CEO with us again, Bill Carregal. Bill, thank you so much for your time here. We appreciate you going into the detail that is necessary to go over these elaborate processes that you and your company are working on. The GlucoChip sounds fascinating. We look forward to great things from you and your company here in 2012, and we expect you back here at smallcapvoice.com so we can learn more about what you're doing in some of these other areas that your company manages. Thanks so much for your time, Bill.
Stuart, thank you again so much. It was great talking to you.
Good morning. My name is Scott Silverman, and I'm the chairman and CEO of Veritech Corporation. Veritech is the world's leader in implantable RFID, or radio frequency identification technology, for human beings. The technology itself, for all of the applications that we're going to discuss here today, is very well protected by a multitude of intellectual property, including patents, patent pendings, and exclusive licenses. The pedigree of our management team here at Veritech runs deep. My partner, Randy Geisler, and I have been the leaders in implantable RFID technology for over 20 years. Randy actually invented the little microchip that you hear about that saves dogs and cats around the world when they're lost, brought to a shelter, and then their neck is scanned and they're reunited with their owners. That technology has been implanted into over 150 million dogs and cats, and on a monthly basis, over 10,000 dogs and cats get reunited with their owners directly as a result of that technology. Shearing Plow Corporation acquired that technology from us and is now operating that business under the brand name Home Again, which for any of you that have a dog or cat, I'm sure you are familiar with the technology and its attributes. In 2004, we took that technology and we evolved it into human applications. And in 2004, we received an FDA approval to put an implantable RF chip inside of an arm through an injection procedure in order to identify a patient and their medical records if they present in an emergency room, in a clinical situation, in order to access their medical records. So high-risk patient, elderly, people that have dementia, people that are in car accidents and unconscious. There was an ability to actually scan the arm of that individual and pull up their medical records. That product was called VeriChip, and we paired that with a complementary operating business in wearable RF technology that many of you are probably familiar with, the little ankle bands that infants get in maternity wards when they're born, a product called Hugs, and a similar technology that's used in nursing homes to help prevent senior wanderings in nursing home facilities. So if Millie the Wanderer goes outside of the area of the building that she's supposed to be in, an alarm goes off at a nurse's desk and she can be retrieved. Those three products, the implantable chip, the maternity ward product, and the nursing home product, were all IPO'd in 2006 in a company called VeriChip Corporation. And in 2008, we sold the majority of the assets of VeriChip Corporation to Stanley Works, the lock and tool company. I wanted to give you that history because it's relevant as to the formation of Veritech. So 3 years later, after the sale of the business to Stanley Works, Randy and I decided to go back into the business. After a series of non-competes, we acquired all of the implantable RF technology from the company that then owned it. And the technology that we acquired started with sensor applications, a broad patent, we call it our seminal patent, to put a biological sensor on the end of an RF chip for multiple applications. The application that we're pursuing today that we'll talk about in a little bit is our radiation dosimeter or dosimetry technologies, but there are also other potential applications in temperature sensing, a chip we've already developed, as well as blood oxygen sensing, and as well as glucose sensing. Neither of those two yet have been developed. So Veritech started in 2011 when we acquired that seminal patent. And we saw the landscape of healthcare change. Candidly, back in 2004, when the VeriChip product was approved by the FDA, it became clear to us that the world was more willing to accept a chip inside of their dog or cat as opposed to a chip inside of their mother or child, primarily for privacy reasons. So what we saw in the landscape of 2011 is that healthcare had evolved. Healthcare had evolved to the point where implantable RF technology can be used for other applications where people would not view that technology as invasive of their privacy as they did back in 2004. Specifically, the FDA had promulgated a rule, which was later signed into law by President Obama in July of 2012, called the UDI, or Unique Device Identification Legislation, which initially had a mandate in it in order to identify all medical devices as they go through the supply chain. So from the point of manufacturing to the shipping to the doctor's office to the OR to the hospital and then inside the body. Our product can actually work and does work inside of implantable medical devices to meet what was called the direct mark mandate of the UDI, or Unique Device Identification Legislation. We believe that our technology was the only technology in the world that has the ability to do that. As the rule evolved after the legislation was signed into law, it became evident that there was no longer going to be a quote-unquote mandate for all implantable medical devices, but rather the mandate was going to apply to reusable and reprocessable devices and parts, things that go in and out of multiple bodies, like breast implant sizers, chin implant sizers, heart valve sizers, colonoscopes, endoscopes, things to that effect. And our technology is very relevant today as it relates to the ability to capture the data from those devices and store the information in our databases as it goes in and out of multiple patients for infectious disease purposes and otherwise. We still have very relevant applications on the implantable medical device side. And in fact, this month, in fact today, we just announced that we have shipped 6,000 of our Q-Inside transponders. We call our chip that goes into the devices Q-Inside technology. And we've actually shipped 6,000 of them to our partners, Establishment Labs, who is a leader in breast implant technology, and they market their products in Europe, Latin America, and Asia. So one of the early movers, early adopters of our Q-Inside safety technology is the breast implant industry. So why? The answer is simple. Back in 2010 and 2011, there was a massive recall of breast implants in primarily Europe from a manufacturer named PIP, or PIP, stands for Polyimplant Prosthetics, Inc. And what happened was they had put industrial-based silicon instead of biological silicon inside of their breast implants, which caused ruptures and caused, obviously, medical harm to the women that had received their breast implants. They were a large supplier in Europe. And still, to this day, the EU has a higher visibility, if you will, as to the quality of breast implants than we do here in the United States because of this specific reason. And that's where our product with Establishment Labs under their brand name Motiva with Q-Inside safety technology is going to be launched. And it's going to be launched in the first quarter of this year through distribution streams that have already been established and are looking to be able to identify breast implants once they go inside of the body using a chip that would look like this chip, and I'll try and hold it up for you, but it's tiny. It is a miniaturized chip. It is about 8 millimeters long. It has temperature-resistant capabilities up to 195 degrees Celsius in order to endure the manufacturing process of breast implants. And the end result is a breast implant like this, which you see has our, if I get close to the camera here, has our Q-Inside safety technology inside of it. And the way that the technology works is obviously once inside the body, this information would be stored in a registry. Currently, there is no requirement or mandate by any country in Europe or elsewhere to actually keep a registry for breast implants or other medical devices for that matter. And our Q-Inside safety technology can act not only as the product that identifies the breast implant or the other medical devices, but also has the ability to tie to a database that can be managed by us, by one of our partners, or in theory, by various governments out there, such as the UDI legislation that's now evolving here in the United States. So just to show you quickly how this works, this is one of our readers. I press it, I scan the breast implant, it pulls up a unique 16-digit identification number, and that identification number would then tie to the database and identify the breast implants of the woman that obviously had received them at some point during the course of her life. So our goal is safety. What we're looking to do, especially in the breast implant industry, which is the early adopters, is to identify these breast implants so that the PIP incident that happened in Europe and is still evolving, and in fact, the CEO recently just went to jail for putting industrial silicone inside of the breast implants rather than biological silicone. We're looking to be the safety provider to evolve the breast implant industry to modern technology, and that hasn't happened in over 30 years, that the evolution of the technology. In addition to the breast implants, one of our other partners is in the vascular port business. Again, a clinical need in addition to the identification need. This partner is a company out of Philadelphia by the name of Medical Components, Inc., or MedComp, and they use our product in order to identify high-speed ports at the point of chemotherapy treatment. High-speed ports can deliver chemotherapy treatment much faster than regular ports, and sometimes up to 6 times faster, so that the normal session can go from 2 hours to approximately 20 minutes. However, up until recently, the only way to identify these high-speed ports was to actually, where the clinician actually felt through the skin of the chest or the arm where the port was, to feel the shape of the device itself, to identify it as a high-speed port. Well, our technology, Q-Inside Safety technology, inside of the high-speed port can not only identify the port for purposes of the UDI legislation, but can also identify the port for clinical purposes. So I'll do the same thing again that I did before, and you'll see that it pulls up a different 16-digit number and identifies the vascular port as a high-speed port for purposes of delivering the chemotherapy treatment. So these are some of our initial partnerships. We have contracts in place with establishment labs in the breast implant world. We're working with many of the other breast implant manufacturers around the world, both on their breast implant sizers that are used during the operation or the procedure to see which size fits right in a specific woman before they go to the final implant. And that can be used in 10 different patients. Thereby you see the mandate that I talked about earlier for the UDI legislation of identifying reusable and reprocessable parts. Vascular ports, obviously another partner as it relates to identifying high-speed ports and meeting the legislation or that the FDA has put into place. And this holds true for all medical devices, hips, knees, pacemakers. Obviously, all of these products, all of these devices with time are going to need to be identified through a direct mark per the FDA legislation, the UDI legislation. And we believe, again, that our technology is very unique and perhaps the only one in the marketplace that has the ability to do that from inside of the body. So that takes care of our UDI piece of the business. And if you're looking through our PowerPoint as I'm going through this presentation, you'll see that the projections that we have related to the UDI business are fairly significant and are based on the mandate that we talked about for the reusable and reprocessable parts and for the market opportunity that we have for the early adopters regarding the direct mark of implantable medical devices in order to comply with UDI legislation as it evolves. Back at the beginning, I had mentioned that we acquired a patent to put biological sensors on the end of the chip. We've really built up that portfolio. We've acquired some technology, we've developed some further technology of our own, but where we have landed on the sensor applications for our initial business model is in radiation dosimetry technology. The ability to measure radiation dosage directly from inside the body through an RF chip that actually goes into a tumor or next to a tumor, or an adhesive that goes on the skin as the radiation beam is going into the body from the radiation machine. Today, just as a side note, today radiation dosage is actually measured from the machine delivering the dosage itself. It is supposed to be calibrated for every patient, and as we know, it sometimes is ineffective, resulting in underdosage, which doesn't deliver the required treatment, or in a worst case scenario, overdosage,
that ultimately can occur in death. And for years now, the FDA and the AMA and organizations like that have listed radiation overdosage as a top 10 concern for years and years. People actually die from radiation overdosage, and the primary reason for it is clinical error because people are not calibrating the machine that's delivering the information, that's delivering the dose, or that the dose being delivered to the tumor site does not equal the dose that's being shown on the machine that's delivering the dosage. So we have developed a technology. We call it our Q-Inside Dose Tracker, which you see here is a slightly larger chip than the one that I showed you before, but this has sensing capabilities. This product has been approved by the FDA already for prostate and breast tumor applications, and there are further approvals that we'd like to work on for liver, lung, other cancers as well. But the functionality of this product is very unique and is like nothing else before in the market. It has the ability to mark the location of the tumor so that the radiation beam can be localized and centralized on the tumor itself, as opposed to hurting the ancillary tissue that perhaps does not have any cancer. And there are other products that do that in the market. But what we do that is very unique is we have a scanner that sits in the delivery room, in the clinical room, and actually reads the radiation dosage directly at the tumor site. That is what sets us apart. That is what makes our IP so strong as it relates to the dosimetry technology. And obviously, as we move into markets for oncology and radiology, this is a product that had already been in the market before under a prior company unaffiliated with us before we acquired the intellectual property, and was very well accepted by the oncology suite, and we look forward to start marketing that technology again. What came along with that technology is a product that we call OneDose. And OneDose, as I talked about earlier, is an adhesive. Rather than being an implantable product that goes inside of a tumor, like the Q-Inside Dose Tracker that I just showed you, this OneDose actually goes on the skin where the radiation beam is being delivered, and again, takes a reading as often as the clinician would like as to the radiation beam and the dosage levels as it penetrates the skin into the body. So this product is actually delivered to the clinicians like this. And all of these things I'm talking about right now are approved by the FDA, have Medicare and Medicaid approvals that go along with it. So this is not something that is new and has to go through FDA approval processes. All of the products we talked about here today have FDA approval, have intellectual property behind them, which makes us a company that's ready to really move forward in what we deem to be our two largest markets, which are the UDI markets that I talked about earlier, specifically for the medical devices and the reusable and reprocessable parts, as well as the radiation dosimetry markets. Now, an interesting piece that comes along with this is data. You know, we all talk about data. Obviously, these products that you just saw have the ability to take very unique medical information, either about the device itself, a medical device inside your body, or dosage levels from radiation treatment, or in the future, potentially other biological readings from a sensor on the end of an RF chip inside of your body. We have a data group based out of our office in St. Paul, Minnesota, that is working with various universities and various device manufacturers to put together the appropriate database in order to collect all of this information, be able to use the information for purposes of that specific patient in the form of a simple personal health record or something to that effect, but going one step beyond, ultimately to be used for predictive medical outcomes for future patients. So using the data that's collected from current patients, using our Q-Inside safety technologies and our OneDose applications, there is a significant ability to collect that data and ultimately use that data for the benefit of current patients, for the benefit of future patients, and even for the benefit of the FDA and other regulatory bodies, if they so desire, as it relates to putting together the registries that everyone is now desirous of doing as it relates to medical devices and other medical information as it evolves. So Veritech is young. You know, we're just about 2 years old at this point. We went public back in July of 2008, or excuse me, July of 2013, I'm sorry, as we merged with a company by the name of Digital Angel Corporation. The Veritech shareholders ended up with about 88% of the combined company after Digital Angel did a reverse split. We recently received a round of bridge financing in order to continue the operations of the company and in order to capture the market opportunity that exists over the next 2 years, specifically in the UDI business as well as the dosimetry business. But the UDI business is the one that has the time frame on it by legislative mandate and by legislation in general. And we look forward to doing that and obviously increasing our revenue model significantly over the next 2 to 5 years. So if you have interest in us, I'm happy to talk to anybody. You guys can reach out to me at ssilverman@veritechcorp.com or our Senior VP of Investor Relations and Corporate Communications, who is Allison Tomek, and her email is atomek, Tomek, @veritechcorp.com.
Let's talk about UDI, what it is, where it originated, and why. On July 10th, 2012, the proposed UDI rule was published in the Federal Register. That kicked off a 120-day comment period, which ends on November 7th, 2012. At approximately the same time in early July, President Obama signed the FDA Safety and Innovation Act, or FDASIA. In that particular act, there's language that says that the final rule needs to be issued within 6 months after the close of the comment period. That would put it around May of 2013. UDI has its origins in the 1999 To Err Is Human report. That report from the Institute of Medicine found that as many as 98,000 people die in U.S. hospitals each year as a result of medical errors that could have been prevented. To minimize medication-related errors, the FDA in 2004 issued the Medication Barcode Rule. The rule, which went into effect in 2006, required that certain human drug and biological product labels carry a barcode consisting of the National Drug Code, or the NDC. At the same time, the FDA looked into creating a similar rule for medical devices, but they discovered that there was not a comparable standard identifier to the NDC for medical devices. That set the wheels in motion for language that was included in the FDA Amendment Acts of 2007 that would require unique device identification. The concept of a unique device identifier, or UDI, is designed to promote patient safety. But as the FDA has worked to create a rule for unique device identification, it's looked at other uses of a UDI, such as things like better supply chain efficiency. The FDA recognizes that if they can identify all of the different uses, all of the different ways to leverage a UDI, they can avoid some of the low adoption rates that they've seen for the Medication Barcode Rule. If the dates in the proposed rule stand, the first devices that would need to comply with the UDI are Class 3 devices. Those are primarily implantable devices, things like coronary stents and replacement joints. They would need to comply or bear the unique identifiers within 12 months after issuance of the final rule. A second batch of products that would be required to bear the unique identifiers within 24 months after the final rule is issued are a class of products defined in the FDA Safety and Innovation Act. They define those devices as devices that are implantable, life-sustaining, or life-saving. The next batch, 36 months after the final rule is issued, are the Class 2 devices. And then 60 months after the final rule is issued come the Class 1 devices, although many of them may be exempt from the rule. The FDA is interested in comments from manufacturers, providers, and any other interested parties on the proposed rule. Remember, you have until November 7th of 2012 to get those comments in. You can visit this website to read the rule and to see a list of questions that the FDA is interested in getting your comments on, or you can simply comment on other matters of interest or concern to you.
Welcome to Digits. I'm Steve Russolillo. Google has officially filed a patent for a wearable electronic skin tattoo. Wow. The product is a temporary blemish that will be applied with a sticky substance to the skin and can be used as a lie detector as well as a link to other mobile devices. Will this idea revolutionize how we interact with technology? For an answer, we are joined by Ryan Pamplin, co-founder of Brand Ads, a video ad measurement company. Ryan, thanks so much for being here with us.
Thanks for having me.
Yeah, so talk a little bit about this idea here. I mean, and this patent. I mean, this sounds crazy.
It does. It sounds like one of those sci-fi kind of ideas. But, you know, I think what we're really looking at here is one small piece of a much bigger wearable computing platform that doesn't quite exist yet. And I think it's going to make a lot more sense when we see all the other pieces that go to the system.
So what's the future for this, both the short term and the long term here? I mean, is this a potentially profitable idea here for Google?
Sure. I think, you know, wearable computing is absolutely the future of computing. And, you know, this is kind of the input device for whatever that future wearable computing device is. And it's absolutely going to drive a lot of revenue for Google because it's a whole new area. But this is really just a small piece. So on its own, I don't know if it's going to drive revenue. But as a whole system, absolutely. Big opportunities on the horizon.
We're seeing an image there. I mean, when I think of wearable technologies, at least right now, I think of Google Glass. I mean, this seems like such the next step in that sort of evolution. So one, I'm wondering if that's the case, and two, the idea of this being calling it a tattoo. That's sort of an interesting sort of. It's a branding opportunity, or why use the word tattoo here?
Calling it a tattoo is something that puzzled me too initially. Although, you know, it's doing a great job of getting the press talking about it and getting people interested and excited. If they just called it a throat microphone, I don't know if that would have the same impact as a tattoo. But it's really a sticker with a microchip inside of it, which is going to have some sort of power source embedded as well. It's unclear exactly how it will work technically, but you know, the idea is to apply it here on the throat and then have it wirelessly communicate with another device that actually will connect you to your network.
What's the practicality of this product? I mean, is this something that we are going to see tomorrow, or is this something that's way down the road here?
I think, you know, it's not something we're going to see people wearing around tomorrow on their necks, but it's definitely something that we're going to see within maybe the next decade or so as wearable computers become the norm. Imagine a scenario where you're not wearing glasses that can have a bone conduction sort of microphone behind your ear like Google Glass, but imagine a future where you've got Google Contacts, you know, or whoever makes the device and wins this wearable computing war. How are you going to get audio from that wearable screen in your eye? You've got to have some sort of microphone. And if you've got something as convenient as a contact, you're not going to want to carry around a microphone. So putting it on the throat, when you think about it in that context, actually starts to make a lot of sense.
And it's not just humans, right? This is also going to be possible for animals?
Sure, the patent does mention animals. So imagine a scenario where you've got a robotic voice, you know, from your dog telling you he's hungry or that he loves you. Or better yet, using the lie detector function, know when he's lying to you.
That's just unbelievable. And so how, for your company, Brand Ads, how does all of this sort of relate to what you guys are doing and what you're trying to achieve?
Sure. Well, we measure digital video ads for brands and agencies. So thinking about how this fits into advertising, you can imagine a future world where, you know, you're having a conversation with a friend and your device knows what you're talking about. Maybe you say you're thirsty and all of a sudden all the outdoor ads all of a sudden are targeted at you with beverage ads, you know, Coca-Cola, Pepsi, you know, Fanta, whatever.
All right, Ryan Pamplin, co-founder of Brand Ads. Thanks so much for joining us.
Thank you.
There you go.
From MRIs to EKGs, sonograms to scanners, medical technology allows doctors to monitor vital information about the inner workings of the human body. Imagine if some of these machines could be made so thin, light, and portable that they could be attached right to the surface of your skin and go wherever you go.
There's some very sophisticated device functionality sitting on my skin now.
Two NSF-funded innovators have done just that by engineering something called an electronic tattoo, a microelectronic health monitor that has the potential to revolutionize the field of healthcare technology.
The electronic has always been rigid. To make electronic flexible, that's quite a challenge.
The path taken by John Rogers and Hyun-Gong Huang to develop the electronic tattoo is an example of how collaboration is often a key or critical part of the innovation process. It all started in 2005 when both men worked at the University of Illinois at Urbana-Champaign, and Huang happened to stop by a lecture Rogers was giving on campus.
Then we started talking, and we find John's work very fascinating, and John found my work on mechanics useful. So naturally, the two of us evolved and worked together.
At the time of their first encounter, Rogers, a material scientist and electrical engineer, was looking for new ways to use electronic circuits formed on the surface of silicon. Silicon is a natural semiconductor that has electrical properties between that of a conductor, a material in which an electrical charge can flow freely, and an insulator, a material that doesn't conduct an electrical charge at all. Semiconductors are the heart of most electronics today.
So at a very simple level, you can use a semiconductor like silicon as a switching element to turn electricity off or on.
Huang, a mechanical engineer who has since moved to Northwestern University, specializes in the mechanics of curvilinear materials, which have surfaces that are wavy.
Curvilinear surface means it's a surface that's not flat. That's not, for example, my hat. The surface is curvilinear.
By combining their fields of expertise to hatch the initial idea of the tattoo, they set out to manufacture a prototype, something that has taken about 7 years and multiple breakthroughs to produce.
But one of the key things is to make electronics as flexible as possible that can follow the skin morphology.
The first breakthrough happened when they figured out how to slice off the surface layer of a silicon wafer. This new technique resulted in silicon that could bend, just like this single sheet of paper. Next, they discovered how to make silicon elastic, allowing it to be either flat or wavy in shape.
Suddenly you have a form of silicon that can bend, it can stretch, it can deform, it can coat and conform to curvilinear shapes, very much like biological tissues.
Even though it is called a tattoo, there is no need to pierce or puncture the skin. Instead, the device sticks on.
So what we can do then is we can take this device, laminate it on the skin, almost like a children's temporary transfer tattoo.
To figure out how to engineer this, Rogers and Huang looked to nature, noting how easily lizards stick to walls.
Like gecko and others, they can easily attach to a wall and easily let go. So for us, we want to borrow some of that idea and to make the electronic not using glue to have strong adhesion with the skin.
Once attached, it can wirelessly detect electrical signals from inside the body, such as those given off by cells within the heart that cause it to contract and pump blood through its 4 chambers.
This particular device is powered inductively. So there's a coil here. I can bring a wireless power supply in proximity to this device and deliver power to it through the air.
Rogers and Huang filed at least 10 different patent applications with the U.S. Patent and Trademark Office to protect their invention before commercializing it. Patents allow inventors to acquire what are known as intellectual property rights to their inventions for limited periods of time.
The intellectual property is absolutely crucial. If that's not done carefully and thoughtfully, and if you don't really have distinctively new ideas that are well separated from things that people have tried in the past, it won't be viable. You won't be able to commercialize it.
A startup company called MC10 has licensed the multiple patents and patent applications and is developing a new generation of flexible healthcare devices.
While doing mechanics work, I never thought that I would have so much interaction with electrical engineers or material scientists, but now it's really at the interface we create new devices that never existed before.
Innovation brought to life by a unique and long-lasting collaboration that has the potential to stretch the limits of modern healthcare technology.
sir. Forgot your receipt.
Checkout lines. Who needs them?
Have a nice day.
This is the future of e-business.
How's your bank account looking these days, folks? Apparently, Americans they're up a little bit. And they're up in large part because the stock market up about 31 points right now on the big board on a Friday. And when massive foreign trade deals are made, they are done in U.S. dollars, which serves as the world's reserve currency. Now the UN is backing a plan to change all of that and create a new global currency. If that's the case, what does it mean for you? David Lee Miller is live in New York. David Lee, good morning to you. How serious is this idea?
Right now, it is not very serious, but it still poses a threat to the U.S. This, of course, is what we're talking about, the U.S. dollar. And who doesn't love the U.S. dollar? Well, as you point out, apparently some economists at the United Nations, they issued a recent report at the UN Conference of Trade and Development just a few days ago. And that report said that part of the world's recent financial crisis is to be blamed on trade imbalances as well as the current system of currency and capital rules. But like it or not, Bill, the dollar remains the most popular currency in the world. It is the standard by which all other currencies are judged. When you trade commodities anywhere in the world, what do they use? They use the U.S. dollar. Beyond that, just about every country has reserves in the event of a rainy day, and those reserves are U.S. dollars. Why U.S. dollars? Because they are seen as the most stable. But critics point out that developing countries that have dollars are essentially giving the U.S. an interest-free loan. And now, if the UN were to get its way, that would be not only a blow to U.S. prestige, but it could also cause problems with the economy if trillions and trillions of dollars theoretically were to be poured into the world economy. Niall Gardner of the Heritage Foundation points out that the UN, with this report, is essentially just taking another swipe at the United States. Here's what he had to say.
This is certainly a direct assault by the United Nations on American global power. This is certainly an effort, I believe, to try and undermine the dollar as a global currency. And the United Nations does have a long track record of anti-Americanism. This is just the latest example of the UN taking a swipe against the United States.
And one other very quick concern, the chorus against the dollar could grow if, as some critics say, the Obama administration continues to increase the U.S. deficit. But if there is going to be any change, Bill, it could be years or even decades away.
Wow. David Lee, thanks. David Lee Miller live here.
Bitcoins are booming. The price of one unit of the digital currency jumped during the past few weeks from about $40 to nearly $150. For anyone who's ever suffered the incompetence of a bank or bristled at fees involved in spending money, the promise of Bitcoin is a kind of holy grail of payments. Bloomberg's Olivia Stearns is with me now. So, Olivia, we know it's a digital currency. We know there's some pizza shops in California that accept it, some other businesses as well. What else do we need to know?
Well, you know, Deirdre, Bitcoin is this brand new form of cash, but nowadays it is behaving a bit more like a good old-fashioned bubble. The trouble is Bitcoin was designed as a currency, but today it's trading more like a commodity. So I'm going to try to explain this in English. Let's start with what it actually is. Bitcoin is a digital, virtual, online currency. It was created back in 2009 by a Japanese hacker who goes by the same name. The product itself, well, this is the confusing bit. It's just simply an algorithm, but it can be traded and used like cash to buy goods and services online. Well, how's it different from real currency? For starters, it's not pegged to anything. It's also totally unregulated, totally anonymous, and the big kicker, there's no central bank controlling the money supply. So that's why, Deirdre, some say it's a hedge against the entire global currency system. You know, effectively, the value of any currency is tied to your faith in the institution issuing it. So here, there's nothing to trust, no central bank, no in God we trust. You just have to trust the math. And that's why some say this run-up in Bitcoins is a response to this sort of macro environment of hyperactive monetary policy, and in particular, fear of a bank run that we saw grow around Cyprus. So people are losing faith, Deirdre, in hard currencies and traditional banks, and they're looking for a new store of value, buying up these Bitcoins. Deirdre?
Well, they certainly are, and as you point out, Olivia, it is a lack of confidence in the currencies that we normally use used, but as you said, this is based on math, so then there are extra security issues as well in that it can be hacked just as easily as it was created. But I'm just curious, remind us about some of the things. I mean, I referenced the pizza. What else can you buy with Bitcoins?
Yes, well, as you and I have been talking about, you can buy everything from a pizza slice to a dozen roses. You're never actually going to get your hands on a single Bitcoin. The idea is to stash them in your online wallet. There are nearly 1,000 e-commerce sites, though, today that will accept Bitcoins in exchange for a whole array of services. And the number is growing rapidly, even though there is so much volatility around what a Bitcoin is actually worth. The price of one has quadrupled since early March. Will they replace hard currency? Probably not. It's still an extremely niche market. Only 11 million have been, quote unquote, minted or mined. The market cap is still shy of $1 billion, but that is bigger than many expected. So if you're looking for a safe haven, Deirdre, you might want to start considering virtual cash, but many say this is pure speculation and it's likely to pop like a good old-fashioned bubble.
Hello, this is James D'Angelo, and welcome to the Bitcoin Minute. With the Forbes Online article this week interviewing Rob McEwen, once again we are given a glimpse at Bitcoin's potential to unseat gold. The billionaire head of McEwen Mining and previous owner of Goldcorp conceded that it's a mistake to write off Bitcoin as a bubble or fad. And industry insider Naval Ravikant of AngelList goes further, saying that all the things that gold does, Bitcoin does better, leading others to the conclusion that Bitcoin is gold on steroids. Indeed, gold, the ancient currency, was once prized for how easy it is to recognize and transport and how difficult it is to counterfeit. But in this global economy, the weight of gold is now its greatest burden. Gold is a nightmare to transport and impossible to send over the internet. While Bitcoin has the very sci-fi aspect of brain storage, Bitcoins, unlike any other money, can be stored just in your mind. Clearly helpful if you're crossing government borders. Further, modern counterfeiters have challenged the most pristine aspect of gold, with many recent forgeries being crafted with tungsten, an element with nearly the same density as gold. In a recent case in New York, hundreds of thousands of dollars were lost to complex tungsten-based gold forgeries. Indeed, as Bitcoin appears entirely exempt from counterfeiting, its wider use could save billions in policing and losses from forgery. Bitcoin and gold are often compared in terms of scarcity, creating true deflationary currencies. But while gold can always be pulled from the ground, Bitcoin has a hard limit of 21 million. And once reached, no more will ever be produced. While it's possible to subdivide each Bitcoin into millions of units called Satoshis to maintain its fluidity, even Satoshis have a fixed and hard limit. With all this, it appears that gold might be running into the same pitfalls that newspapers and music companies felt when hit by digital online alternatives. It appears that with crypto technology, for the first time in history, gold has met its match. When it comes to inflation, transport, trust, counterfeiting, and usability, Bitcoin stacks up pretty good against a precious metal. So, as gold prices tank in recent months, one can only wonder if Bitcoin's surge and Cyprus's troubles have anything to do with the fall. And others have suggested that as Bitcoin's price multiplies ever higher, bringing the masses further into the fold, whether we are seeing the beginning of the world's first digital gold rush.